Okay, everyone, thank you so much. Please feel free to take your seats for this wonderful new panel by Coesia on enhanced customer experience when unboxing e-commerce goods. This is a very timely and important topic, of course, and by some experts here. I'm going to start by having the panelists introduce themselves to you each, and then we'll get into some good questions and dialogue. Samuel, why don't you go first?
Hi to everybody. Thanks for being here. My name is Samuele Mistrello, Sam. I'm Italian when I'm born and raised. And in Coesia, I will explain to you who is Coesia later on in a few words. I'm the e-commerce business leader. For us, e-commerce business leader or e-commerce stands for e-commerce automation. Who is Coesia? Coesia is an Italian headquartered company, but with a global footprint. We have basically 2.1 billion of turnover. What we do is engineering and manufacturing equipment and automation for material handling or industrial manufacturing. In US, we are based in Allentown. We are based in Minneapolis. We are based in Cincinnati as a manufacturing plant, and then Philadelphia. We have operations here in Cupertino too.
Mark?
Good afternoon. My name is Mark French. I work under one of the 21 companies underneath the umbrella of Coesia. It's FlexLink System. Again, we're based out of Allentown, Pennsylvania. I'm actually located in Nashville, Tennessee. So I'm the general manager or the SBU manager for the e-commerce and special projects. So Sam will talk about today mostly about the e-commerce side, and I want to talk about something of the special project stuff that we're handling, creating, building for the e-commerce side.
That sounds wonderful. So why don't we get into it with a couple of questions, if that's okay?
Yeah.
So I'll pose this first one to the group, and basically it's something that has been on my mind a little bit, and I just want to ask to you all. How can Coesia Pack Automation Solutions address e-commerce order fulfillment challenges?
The answer is with the automation solution that are specific for order fulfillment. And in this case, the solutions are basically either box or bags on demand, right sides, smart automation, with the objective to address the needs when it's necessary to do what? When it's necessary to safeguard the goods, the e-commerce goods during the delivery journey, will be important to generate a positive customer experience when the customer unbox the e-commerce goods received, and provide value thanks to the fact that either the bag or the box on demand right sides might have a direct print on demand, which a custom, unique message intended to be delivered to the intended receiver. Then, either the bag or the box. Here is very shortly a portfolio of solution, bag or box on demand with digital printing and software necessary to enhance this customer experience. Sustainability. When we refer to the box on demand right size in the e-commerce business sector, statistically, there is a statistic say that roughly 40% of the box shipped out during the delivery journey has a void. 40% of voids into the box. So let's understand what does it mean. If you might have the possibility through an automation system to reduce the box dimension up to 40%, therefore avoid to ship out air, you reduce 20% of raw material. But if you reduce 40% the box dimension, you can load 40% more per truck. If you can load 40% more per truck, you can reduce your shipment cost. But ultimately, if you load 40% more per trucks, what you reduce is your carbon footprint generated. What does that mean in terms of sustainability? It means the CO2 that your business generates and emit in the atmosphere. Okay, sustainability. So saving and sustainability. Box and bags on demand. The box and them on demand, right sides. The minimum can be the equivalent of a mailer. The maximum can be a quarter of a pallet. Are produced on demand and print on demand with different characteristics according to the business sector. Fashion industry, beauty and care, electronic consumer goods has different needs in comparison to consumer goods. Okay, here is an example. For instance, this is a box on demand, right size, produced according to the characteristic of the products that will be placed in with cushioning, dynamic cushioning. Dynamic cushioning is why? Because when you have an electronic consumer goods or a beauty and care products, make an example of a perfume or a smartphone, deliver at home to the intended receiver, and the box is unscratched, undeformed, but then the perfume in is broken because there is glass, or the electronic consumer products few days later start to not function properly because the electronic board in was the delivery journey exposed to a stress, kinetic stress, okay? The electronic board absorb energy because it fall down. There is no evidence of the deformation, but as a matter of fact, there is. These kind of boxes are designed with the objective to guarantee that we create a dynamic cushioning according to the weight and the characteristic of the products that has to be packed for the delivery journey. And then easy opening, tear tape, resealable, all the stuff also for reverse logistics, therefore when the box has to be shipped back because the consumer is not intended to keep the goods that has received. Or a software. You might have cases where your order is composed of different SKU with different content, profile, characteristic, dimensions, shape. What does the software do for your specific order? Aggregate the data and define what would be the position and the right sequence of product to be combined. Then the automation produces a box on demand right size for the specific order to be produced and handled. Then either a manual workstation or robotic station receive the box on demand right size, and the operator follow the instruction on which SKU to be placed into the box in which sequence. What is the objective? No errors and optimize the operation. A bag on demand, okay? Bag on demand. What does it mean, bag on demand? Usually when you have a bag, you have mailer, here in USA, is said, okay? In Europe, for instance, because I'm coming from Europe, I'm sorry for that, we get rid of whatever stands for poly, P-based material. So the European regulation obliges all to have basically a paper-based or totally recycled material for a bag. Here is the operating principle, a simple operating principle of a machine. You scan an SKU, you load the SKU on the process. There is a 3D scanner that reads the data dimension of the SKU. The dimension of the SKU, once read, generate an algorithm that calculates what has to be the bag on demand to be produced. If it is wrong, the SKU is rejected. Automatically, the machine increase and reduce the speed according to the number of SKU inducted, okay? Therefore, there is no need for the operator to increase or reduce the speed of the machine because the machine itself adapts to what is needed. You might print and merge a document, an invoice, a lifter, a bill of material, to the relevant SKU that has been inducted, and then the machine starting with a plain raw material delivery roll, craft paper, tear tape for easy opening, resealable tape for the return of the goods, basically merge with the product inducted, the algorithm calculates what has to be the bag on demand to be produced, and there is the process of wrapping around. We wrap around the product, the algorithm define what has to be the dimension of the bag to be produced. In this case, was for fashion industry, therefore the maximum dimension was the equivalent of a shoe box, and then the bag is automatically wrapped with the product in, print on demand, shipping label, print and apply, and ready for the outbound, okay? This is a simple solution specific for pack automation when we are referring to bag on demand. Then we go to box. The simple box on demand is the American box, what we call here in US the RSC. In this case, the box has a double layer on these edges in order to make the box stronger than any box that you might find on the market, and therefore also reduce the flute thickness and characteristic that you might use. The box will be the equivalent of a minimum of a box, maximum of basically what could be a quarter of a pallet. The material delivered will be a corrugated cardboard in fan folds. And what is the operating principle of the machine? Again, based on the SKU or the SKU data, and there is not available, a 3D scanner can read the information. The machine, starting from plain corrugated cardboards delivered in different width, cut and increase the quantity of material necessary for the manufacturing of a box on demand, right size, And here you can see simply the operating principle of the machine that cut, crease, and then remove the exceeding quantity of material that is not necessary for the box on demand right size calculated for the specific order on demand. Once all those pieces are ready to be combined, and here again you see the operating principle of cutting, creasing, and removing the edges of the material that is not necessary. What really counts is the total material consumption. Therefore, for the box on demand that you need to use as much as possible material, reducing the waste generated. And here you see how the box, in this case, on demand right size, is erected and then delivered to the next stage, if you wish. Not necessary is an option. That print on demand on the outer of the box, any data that you want, okay? A barcode, brand, message that you want on the box. And the box sent out to our conveying system that are produced here in US in Allentown can be delivered through a working station, manual working station or robotic station that detect the box, recognize the ID of the box, and pick and place the specific SKU that is intended to be for the right size box that was designed for. And here you have an idea of an operating principle designed for one of our distinguished American customers, that the box on demand is delivered on demand to the intended working station, which has the duty of fulfilling the order's operations. Okay. Here you see also there is a buffer. Why the buffer? Because if the operator is not standing or operating that moment, the box can be accumulated, the box are equipped with a barcode, the operator scans the barcodes, and as a consequence, the operator has a facilitation on how to process the orders.
That is extremely impressive. Very, very impressive. That entire system is just unbelievable. My second question for you is, how does Coesia Automation support e-commerce players in enhancing the customer experience?
Here you have the answer. The ones that we showed before was a general box, an American box design. Here you have a clamshell box design. The clamshell box design has the objective to enhance the customer experience while unboxing the e-commerce products that has been delivered. Enhance the customer experience, clamshell. Therefore, the first objective is to guarantee, and there is no box on demand, right size equipment on the market worldwide who have such kind of design. Guarantee that the first that the customer see when he's unboxing is the product in. And then having a basically surface that is the inner part of the box that can be print on demand, direct printing. Direct printing, print on demand. Why? Because on the inner side of the box, you can convey a unique message to the intended receiver, a message that might generate a stream of revenue. Let me make an example with the meaning of stream of revenue. I am on your website, I'm surfing and I'm buying the product A and the product B, and I spot the product C, but I didn't purchase the product C. I purchased the A and the B, and you have my data. When I'm receiving my box, and I'm boxing it, you will advertise the product C. And what you generate, an increase revenue. Or I'm buying online and I'm buying a present for my kid or for my girlfriend or for my wife, whatever, okay? I can pay you an additional fee if you allow me to print on demand on the inner side of the box a message that I want to convey to my intended lover, okay? And what is the benefit? You generate a stream of revenue and you generate an higher customer experience. Last but not least, you are a 3PL or you are a company that manages multi-brands because it has business partner. You can sell to your business partner the inner part of the box advertisement. So on one side is a positive customer experience because the customer has activation. This is a data available on the market. When you unbox an e-commerce box parcel receive, the brain activates the same neurons of unboxing a present. Even though you know that inside there is just a shampoo, as a matter of fact, the brain activates that part of the neurons. And any message conveyed to the intended receiver in the moment of unboxing has 3 times more effectiveness than any message delivered during the day. So the operating principle in this case of the machine is you induct the SKU or the multi-SKU. Once inducted, the machine automatically read the data. Data, what does it mean? Read basically the barcode of the SKU or the multi-SKU, deliver the data that we read to your WMS system. You return to us the confirmation that the product is sold. We scan the product in terms of 3 dimensions. We confirm to you basically product ID and the product dimensions. We calculate automatically what will be the box on demand right size to be produced, therefore the quantity of material necessary. If for any reason the SKU inducted is wrong, is automatically rejected, and we'll tell you why. There is no order associated to it. We can print additional documentation, a bill of material, invoice of a message, or a letter that basically someone pays you for having to distinguish the offer that is received. Then the product, the SKU, is combined with, in this case, the paper. The box is manufactured as we showed you before, cut, crease, and printed. The SKU, and if it is there, the paper is then laid down on the plain material, which is then wrapped around, closed, sealed, print with a shipping label, print and applied automatically, and either kick out if there is something wrong or deliver to the outbound. And what is interesting here, every single box will be unique. You can have the box number 1 with tier tape and resealable tape for reverse logistic to return of the goods and print, and the next one, no. Unique. Automation that has to be scalable, flexible, easy to use, and with an adaptive speed. What does it mean, adaptive speed? The machine itself stops if there is no SKU inducted. The machine itself accelerates according to the speediness, therefore the volumes, of order SKU that you inducted. User-friendly. It's our mantra.
No, that's absolutely fascinating. And I think one of the most interesting things that you said before was about the psychology of the packing goods, about the messages on the inside and how it basically transitions and makes people think as though they're almost opening a present. That's a lot of thoughtful insight into how to do this production process. And I love the fact that every piece can be unique too. That's really very intriguing. Let me ask you, what challenges does Coesia Pack Automation Solutions address in terms of e-commerce fulfillment and process flow?
One of the key in the e-commerce automation, or let me say in processing an order, therefore order fulfillment, is to have 0 errors. Okay, an automation guarantee that thanks to the software in control and the system embedded in automation, every single SKU inducted is associated to an order, is tracked and traced, the data are automatically gathered and real-time controlled. Second point is scalability. Therefore, an automated solution that might have the capability to cover the different seasons that you have in e-commerce, peak season, low season. Therefore, a solution that adapts itself in terms of speed and performance, throughput, real time. Last but not least is scalability. Therefore, a solution that has the capability to increase according to your needs. And ultimately, when we are in a distribution center or in a fulfillment center, the machine has to be very easy to use, extremely easy to be managed. No need for operators, particular training or particular competence.
What about resolutions regarding efficiency and reliability? So can we talk a little bit about sort of the user-friendly aspect of some of this machinery?
In a distribution center or a fulfillment center, what counts is the guarantee that the operator have the possibility to use friendly and interact with the machine with the objective to be reliable, with the objective to be efficient, in the objective to be sure that whatever order you need to process in the real time is 100% executed. This is the meaning of reliability. 0 errors and accuracy.
Is zero really possible, or is it a matter of being as close to zero as possible?
0 is really possible in what sense? In the sense that if for any reason is missing one of the data, okay, or make a very simple example. You forgot to fill the ink for print on demand, okay? The machine will kick off the order because the ink is missing, or the data, the barcode on the shipping label is not readable. Therefore, 0 error means whatever you have in outbound, so ready to be shipped, is 100% guarantee that is correct and accurate.
Understood. And you talked a little bit about the flexibility and the scalability. Can you tell me a little bit more about the scalability side of it on the fulfillment center's needs?
What is the challenge of a fulfillment center? The season. Big season, low season, important days like Black Friday and whatever, where basically the peaks are so high that it's not easy to be managed such volumes in a short period of time. And then you have low season, but as a matter of fact, few operations are more than enough to cover whatever are the needs of the day. This is scalability, a solution that adapts itself automatically without the need of resetting, tuning, or an operator that carry out a setting of the system. The machine, the equipment and the process flow itself adapts intelligently to the real-time need of throughput.
I think that sounds fascinating. I mean, I'm very impressed with what I'm seeing here. I've never really seen the level and the breadth to which you're doing this, and I think it's just unbelievable. You want to turn this a little bit over to Mark and have Mark?
My pleasure.
Thanks, Sam. So what I'm going to do is present a little bit about one of the companies that makes up Coesia. It's called FlexLink System. So FlexLink System is basically a subset of one of the 21 companies. We've been in existence for 43 years. We have over 1,000 employees. We're in 60 countries. We do a little over 300 million in sales. And we typically have about 5,000 projects, individual projects, unique projects that are one-off for every individual company that has something specific that they want done. Our main headquarters is based in Gothenburg, Sweden. And again, our U.S. headquarters is in Allentown, Pennsylvania, but we also have other facilities throughout the country. One of the projects that we worked on this year, or we've started on journey a couple of years ago, is called the digital sorter solution. What this is a linear motor system that has the ability to create carriers. And the carriers, what we'll do is we'll take the product of what you need to be dropped off to certain areas, as you can see in this application. So we'll talk about the markets and applications, the couple of the technical platforms that we have designed, and maybe at the end here, we'll have some questions for Samuel and myself. So the industry segments that we look at right now that we're applying towards this concept is in the pharmacy, in the e-commerce, and the logistics fulfillment areas, and also in the application sides. What we're looking at is you're able to sort individual components. So think about in a pharmacy where you have hundreds of orders of prescriptions come in. Those orders need to be somehow sorted either into the retail stores where they'll be delivered to by the customers picking up, and or it will be distributed by zip code, area code, where they're going to have to be shipped to. So this system has the ability to sort all those individual products and sent to accordingly to the proper code that they get to send to somewhere. We also have the ability to sort into totes or Gaylord packages or bags. And then finally, what we talked about, it's a project that we just completed this week. It's about a heavy pallet sortation where we can take a pallet up to 2,500 pounds and we can sort that pallet in the full, upright, intact, and sort it, distribute it to different areas. So we're going to talk about the type of platforms we have. So there's three main platforms we have. The first one is called the hybrid system. Typically, it's a lightweight up to 1 kilogram, or actually it starts at 1 kilogram and go up to about 10 kilograms. And again, it's a sortation that's on a linear motor. So it's very quick, very fast, and can travel up to 4 meters per second. And the carrier type can have different types of trays or components. It could be a flat belt conveyor that has a roller that can roll off of it. It could be a tilt tray, or it could be a stationary fixed platform that could be delivered to an operator or induction point. The second system is called a quick stick digital sortation. This is probably our medium to heavy capacity, where it starts at a load about 10 kilograms and go up to about 180, 200 kilograms. Again, it can travel up to about 4 meters per second. So imagine 1 second it travels 12 feet down the road. So we're able to move these things very quickly and digitally and, across the system. And the last thing we just finished the project is called the Quick Stick HT, or high thrust. We have the capability of about 2,500 pounds. It can go up to 2 meters, possibly up to 4 meters per second, but I really wouldn't advise that. If you can imagine something that heavy and has to stop or turn, you're probably going to tip it over. But we do have the capability on the return side where this carrier can return back to the induction point very quick, very fast, versus your conventional roller conveyor chain link type style. This digital sortation started several years ago, and here what you see is in this concept, we use our conventional flex link conveyor to do the elevation changes. We could do heights changes, curves, turns. And then what happens at the very end, oh, it stopped. We transfer from our conventional flex link system to our MagnaMotion system. I don't know why the video is going, but again, we make that transition to 2 different types of platforms. Do it economically on the FlexLink conveyor system, and then we go to the high-end MagnaMotion Lite system, where the system will transfer over onto that system for a quick, fast sortation. And then through all this, what we do is we maintain the identity of the components that you're transferring. So everything is identified by an RFID token. So we make the transition from one system to another system. We track your components, and we know where it's at all times. It's not running. Okay, in this small demo, here it is. So in this system here, you can see the carriers are running in a circle with the white belt, this cross conveyor belt. It's traveling with the totes. And the totes can circulate, they can be dynamic also, or they can be stationary. And what the carriers will do, they'll circle around to a point where it tells it, hey, I'm at my tote and I'm going to drop it off. The cross belt is activated and it will roll off into the proper tote it gets to. So we could do in totes, we could do in gaylords. You think of big stationary boxes that you need to fill up for fulfillment centers, or we can do it into bags and other types of components that you have. And again, we could do it continuously moving, recirculating, or we can be static and leave everything as is. Talk about the next is the hybrid sorter. Again, here's some of the technical specs here. You can see the min and dimension sizes. Again, we go from about 1 kilogram to 10 kilogram with the requirements for electrical controls. In this example here, we can keep it very simple. Everything we do here is scalable. So in this example here is a very small induction point. An operator, as you can stand there in that bottom left-hand corner, he's inducting a part onto the carrier and he's sorting into bins. So instead of an operator walking around to bins, you can scan and induct, and then this system will carry the part around into the defined totes or crates or gaylords where it's going to drop off into.
Mark, can I ask a quick question?
Sure.
If you don't mind? When it comes to speed, is there sort of a maximum speed that the system, if you kind of look to exceed it, it then creates a scenario of instability within this system?
It does. It's based on the payload capacity that you're wanting to move around. And like in this demo, when you have small components on the right-hand side, you could probably get up to 2, 3, 4 meters per second. But if you had something that's very tall and heavy, I don't think you want to go around that corner at that kind of speed, or it's going to slingshot off, right?
So in the end, let me ask you, if someone had a certain output that they need to have achieved, is that a matter of making kind of a longer run in order to have more product flowing through the system?
It's twofold. So you take the advantage of the speed of trying to meet the maximum speed to get it to the destination source. But once it drops off the product into the tote or the bin or the destination, then you take the advantage of speed to get back up to the destination, to the induction point, because there's no load on it, right? So that's the advantage of the system. It may be slower to distribute into the totes and the carriers, but after it drops off, we want to maximize the acceleration and maximize the speed so this carrier can get back to the front point at the induction point, so load something back on and to be utilized again.
Okay, got it.
Boy, this video here is not running out there. There's a delay. So in this video here, what we also show here is that we have the ability from the carriers to be able to move, but we also will index the totes. So again, it's a dynamic system. The totes do not have to be stationary. We can load empty totes into production, and then at the exit of this, as the totes are full, we can automatically pull those totes out and send it to a final destination, possibly for packaging or relabeling or palletizing or something like that. So we have the ability to make the totes to be automated so operators aren't moving things around. This is a simulation we did using Emulate 3D. So on the left-hand side is what we call a double loop sortation with 4 induction points. You can see those totes are dynamically, they're moving. The carriers are running approximately 2 meters per second. And they're sorting into the totes. This left-hand side here that you're looking at has about an induction rate about 3,500 parts per hour. On the lower right-hand side is what we call our single loop carrier, 2 induction points, and it's about half the volume. It's right around 1,600 parts per hour that we're sorting into. And again, the totes that we're circulating are dynamic or they can be static. In this case, if they're dynamic, as they fill up, we'll be able to pull those totes off directly off the production line and then insert a new tote to take its place. So again, the carrier components here, there's several variations we talked about earlier. We do have a cross belt conveyor that will put a product, the belt is inducted with power and the parts will roll off. We also have on the bottom left-hand side, a tilt tray, and the bottom right-hand is a passive tray that just sit on top that could be, but again, any type of carrier or component could be customized to the customer's needs here. This is sort of what the carrier looks like. It has 4 wheels on the bottom. Again, there's guide rails that will run on a track or a trail inside the wheel wells. And again, there's a magnet array that sits on the bottom of the carrier, and there's a linear motor that sort of propels that magnet forward. And that's how you get the concept of this linear motion: very fast, very quick, very smooth, and very quiet. We can do a double stacked carrier style. If you're trying to increase your space or utilization, you could do an upper and lower type carrier system where you can have 2 type of systems to sort into. We also do accumulation where the contact from the carrier right to an induction point that can be transferred right off to the dedicated point. Again, just a couple other things here we thought of. So you can slug convert the carriers. If you know how you want your carriers to be merged into your main line, you can do it individually or you can release them in slugs. We also could do a handshake between carriers from the MagnaMotion Light carrier system into the conventional FlexLink carrier system. We did this for a customer here. They wanted the components to be dropped off into bags. So we created a bagging system, and the carriers would be running around in circles. And as the bags would be defined for the carriers, it would drop it off. And then at the exit point, the bags would exit to go down further downstream. And then we also had a new induction point here where the new bags would be induced into the system. So again, we're creative. We could build things from a bag, tote, carriers types. And the last thing I want to talk about is something we just finished up here. This is our quick stick high thrust. Again, think of a 4840 pallet size carrier where it can move up to goods up to 2,500 pounds. Again, we can get up to 4 meters per second. Typically, that's the acceleration rate or linear speed rate we'll get when it's empty. But as it's, imagine you have a full carrier weight that's 4, 5, 6 feet high, and that way you just don't want to speed that fast going around the corners and turns. So again, we do have the ability to now transfer up to full pallets in this heavy-duty capacity. So at the end, the digital sorter, I think the software control system is very easily to maintain. It's smart. It's built on a platform that enables real-time analytics, diagnostics. We know where every component is at any time of the system. We can create you the diagrams and chart everything, how the system is running. It's also very modular. If all these tracks, you can add on as you grow. So you can start small, and over time, as things are getting bigger, you need to add capacity. You're just basically unscrewing components and adding new components on to extend your the length of runs or maybe spur lines that you want to add. It's very energy efficient. The carry only moves when it needs to move, or you can always be moving at a lower rate or lower speed. Again, there's some energy operator efficiencies here. Again, since you don't have the traditional rollers that are constantly moving and clanking along, this is, again, a linear motor. Imagine the electricity pulling a magnet that you barely hear as it swishes across the rail system. The software is very dynamic. We can have a lot of mixed points if you want to carry stop specifically at multiple stops, or you can bypass stuff. So you don't know where you want to go. You can bypass until it meets the right tote that needs to drop onto. The biggest thing that we noticed is size allotment. One of the projects we quoted on, they had a project that defined this ridiculous space. It had taken out some pallet rackings. At the end of the day, I realized that we could still meet the same capacity at about a third of the space that they really were looking at. So again, due to the speed, acceleration rate that we can get on the return side, it makes this process possibly to create some space savings on the floor. As I got.
That was very fascinating. Mark, wonderful presentation. We'd at this time like to take any questions from the audience, if anyone has anything for the panelists up here. Any questions from the audience at all? Yes. Do you have a mic?
Thank you. Heath Tilley from Odem. Interested in the cardboard feed system. Is that cardboard specific in its who manufactures it and in its specification? How flexible is it?
Good question. The characteristic of the corrugated cardboard that you can use is of any type, according to what you prefer to have in terms of quality, thickness, therefore the kind of flute. The corrugated cardboard that I show you here was delivered in foam fold, but you can get also delivered in sheet. The equipment is flexible, therefore allow you to use basically any kind of cardboard characteristic, and in two ways, foam fold or sheets. Then, majority of what I witness is available on the market pretty easily. More the manufacturer of sheets, a little bit less the manufacturer of foam fold, but is picking up a lot. The foam fold manufacturing, because basically are the same producer that produce the sheets, the producer that produce of corrugated cardboard. Last question to answer, to mention is, you might have a different characteristic of flute delivered to the machine. So beside to the fact that you have the box on demand, right size, with different features and so on, you might produce also the box one with the flute EB, making example simple, and the next box produced with the microflute, the B, the microwave.
Any other questions for the panelists? Gentlemen, do you have any other closing statements?
Thank you to all.
Thank these panelists for a wonderful presentation on packing and shipping innovations. We learned a great deal. Thank you again.